Okay, so today we're going to work with special right triangles. And we are going to, and I screwed this up a little bit, we're not going to use the Pythagorean theorem again. We are going to use special right triangles to find lengths in these special right triangles. So the first kind of special right triangle we're going to talk about is a 45-45-90 triangle. And in a 45-45-90 triangle, both legs are congruent because it's an isosceles triangle. The part that's important is the hypotenuse is, this is a misspell, the square root of 2 times the length of the leg. And it doesn't matter which leg since they're congruent. So the hypotenuse is the square root of 2 times the length of a leg. So in example 1, finding the value or the length of the hypotenuse, in part A, this hypotenuse h is a leg times the square root of 2. And that is how I would represent my answer. I'm not getting a decimal. I want to leave it in simplest radical form. So this is in simplest radical form. In part B, the hypotenuse x is the leg 2 square root 2 times the square root of 2. So the hypotenuse is a leg times the square root of 2 in a 45-45-90 triangle. So to get this answer in simplest radical form, it's going to be 2 times, and the square root of 2 times the square root of 2 is the square root of 4. So this really simplifies to 2 times the square root of 4, which is 2. That means x is 4. So when I multiply two square roots, I multiply the numbers inside those square roots, and then I simplify that square root if I can. So as far as guided practice, I want you to try number 1 on your own, so you can pause the video. When you're ready for the answer, resume the video, and we'll move on to example 2. So for this problem, if you're given a leg is 5 square root 3, the length of the hypotenuse is that leg times the square root of 2. When I multiply the two square roots by each other, I multiply the numbers inside the square root. That becomes the square root of 6. That cannot be simplified, so 5 square root 6 would be my answer in simplest radical form. Now, in example 2, I just talk about, instead of finding the hypotenuse when you're given a leg, you find a leg when you're given the hypotenuse. So I'm going to just abbreviate the equation we did before. The hypotenuse is the leg times the square root of 2. So if I was going to try and find the value of a leg, I'm going to solve this equation I wrote for L, for the measure of the leg, which means I would divide both sides by the square root of 2. Those eliminate. The leg in a 45-45-90 triangle is the hypotenuse divided by the square root of 2. So in example 2, the leg x is equal to the hypotenuse 6 divided by the square root of 2. Now, this is not in simplest radical form. To get this in simplest radical form, I cannot have any radicals, any square roots on the bottom of this fraction. So in order to rewrite this, I'm going to write this fraction multiplied by the square root of 2 over the square root of 2. And the reason I can multiply by that is because the square root of 2 divided by the square root of 2 is 1. It doesn't change the value of this fraction. Now, the top of this fraction, 6 times the square root of 2, would stay 6 times square root of 2. The bottom, like we showed in the last example, example 1, square root of 2 times square root of 2 becomes 2. So to simplify this fraction, I can divide the two numbers that aren't inside the square root. I can divide 6 by 2. So I'm going to highlight that really quick. I can divide 6 by 2, which is 3 square root 2. You'll notice I didn't divide the square root of 2 by 2. So when we're multiplying or dividing, we can multiply the numbers that aren't inside the square root by each other. We can multiply the numbers inside the square root by each other. Same for division. So in the guided practice, you have the same problem that we just covered, except instead of the hypotenuse being 6, In this problem, the hypotenuse is 10. So just do part A. When you're ready to resume the video, I'll show the answer for part A, and then I'll go through explaining part B. So in part A, you divide 10 by the square root of 2. To simplify that, you multiply by square root of 2 over square root of 2. That becomes 10 square root of 2 over 2. You can divide 10 by 2 to get 5. So your leg, in simplest radical form, is 5 times the square root of 2. In part B, really all I want to do to explain why I multiply by square root of 2 over square root of 2 is that this is equal to 1. It's like you're multiplying by 1. So it doesn't change the value of that fraction. The main reason we multiply specifically by square root of 2 over square root of 2 is because when I multiply the bottoms of these fractions by each other, this becomes 2. I just want you to think of it as eliminating the square root on the bottom. That's all you're thinking of it as. To rationalize that denominator means to get rid of a kind of what we called it before, an icky square root, and get it to be a whole number or an integer or a rational number. So that's why. So on the back side, it gets a little more complex. Now you're going to have a sheet later on that helps you organize these, or a graphic organizer that helps you kind of keep these equations straight. But the other kind of triangle is a 30, 60, 90 triangle. So when we talk about a 30, 60, 90 triangle, we're going to talk about the hypotenuse, which is always, every time, the side across from the right angle. So in this triangle to the right, I'm going to label the hypotenuse H. In a 30, 60, 90 triangle, you have a short leg and a long leg. The short leg is opposite from the 30-degree angle. The long leg is opposite from the 60-degree angle, because a 30-degree angle makes a smaller side than a 60-degree angle. So I'm going to go through the ways you solve for different sides of a special right triangle that is 30, 60, 90. So the first thing is the length of the hypotenuse is twice the length of the shorter leg, the short leg, I'm going to call it. The length of the longer leg is not 13 times. That's my mistake again. The square root symbol didn't get inserted there. The longer leg is the square root of 3 times the length of the shorter leg. So in example 3, it's important you kind of pay attention to the language I use and the words I use, because I want us to know what parts are what. So I'm going to use green again just to label each part. So F is the hypotenuse. D is the shorter leg. 5 is the longer leg. So looking at this, I've been given the longer leg. I want to find the shorter leg in the hypotenuse. What I always want you to think of, if you can, find the shorter leg first, always. Always find the shorter leg first. I think that makes the problems a little bit simpler. So I'm going to use the longer leg to find the shorter leg, because I know the longer leg, 5, is equal to the shorter leg, D, times the square root of 3. Okay? That's how I find the shorter leg. I'm using the equation up here. I'm going to highlight it in yellow. I'm using the second equation up here. Because I was given the longer leg, I want to find the shorter leg. So to find the shorter leg, I divide both sides of this equation by the square root of 3. And pretty much just what we just talked about is how to eliminate that square root on the bottom. So I'm going to multiply the top and the bottom of this fraction by the square root of 3. So this becomes 5 square root 3 over 3. That is the value of the shorter leg, and I know that's hard to believe because it doesn't seem simple, but that's in simplest radical form. And I realize that 5 looks a lot like an S, so I'll try and do my best to write a normal 5. Okay? Now, next I'm going to find the hypotenuse. The hypotenuse is F. So I'm going to use the first equation from up top. The hypotenuse, F, is equal to 2 times the shorter leg. 2 times the shorter leg, which we just found, 5 square root of 3 over 3. So essentially, all I do to simplify this is I multiply 2 by 5 to get 10. So this is 10 square root of 3 over 3. And that is my simplified answer for f. So in the guided practice, I didn't draw the triangle. I'll draw it now. But it says find the value of t in simplest radical form. So I just want you guys to draw a right triangle, label this angle 30, label this angle 60. So to find the value of t, I'm going to label some things. So in this triangle, I'm going to label the hypotenuse 6, and I'm going to make the shorter leg t. So just pause the video, try it, and then when you're ready, you can move forward, see the answer. I won't do example 4 right now. I'll give you some practice after this so you can see the patterns in some of these problems, because most of them are just me switching around the numbers. So pause the video. When you're ready for the answer, you can resume it. So I tried to make this one simple enough. You're given the hypotenuse. You're trying to find the shorter leg. So it's using that equation from the top, that the hypotenuse is 2 times the shorter leg. So 6 is 2 times t. That means t is 3. So that's a simpler one, but you'll get some more complex ones to practice. So you can move ahead to the next part of the lesson.